every second the Earth's crust beneath Iceland continues to shift by about a few centimeters. This slow silent movement has created more than 130 active volcanic systems, formed kilometer-long fissures and released molten lava exceeding 1,100 degrees Celsius, enough to cover and completely destroy an entire town within just a few hours. Faced with that power, humans cannot extinguish an erupting volcano. The only thing they can do is build lava barriers to slow down a natural process that cannot be stopped. In today's video, join Quantivox Tech as we search for the answer to a critical question. Can humans stop lava, or are we merely buying time before nature prevails? Overview. Despite its name as the land of ice, Iceland is one of the most geologically active hotspots on the planet. This island nation lies directly on the boundary between two massive tectonic plates that are continuously pulling apart, allowing magma from deep within the earth to rise to the surface and trigger volcanic eruptions. Most of the time, lava flows only through uninhabited fields of black rock. But when its direction shifts and moves closer to populated areas, it immediately becomes a serious threat. On average, Iceland records about 4 volcanic eruptions each year, and no one can accurately predict where the next one will occur. When the eruption that began in 2023 covered an area of approximately 15 square kilometers, Icelandic authorities responded almost immediately. A large-scale operation was launched. The construction of lava barriers, massive earthen walls with a single objective: to slow the advancing lava flow. The massive numbers behind the wall lava barriers are not structures that are fully designed from the beginning. They are the result of a continuous construction process. Behind the towering wall stands a geothermal power plant, a facility that supplies hot water and energy to a large portion of Iceland's population. If the lava flow were to reach the site, the consequences would extend far beyond the destruction of a single area. The entire daily infrastructure serving tens of thousands of people could be affected. At the peak of the operation, the wall reached a height of approximately 20 meters. Over the course of 6 months, more than 3 million cubic meters of material, primarily volcanic rock and soil, were moved to form this barrier. However, the lava did not stop. When molten rock overflowed the top of the wall, at several locations, firefighting crews were forced to spray water directly onto the lava to cool it and slow its advance, buying additional time for reinforcement efforts. Structure of lava barriers. From a structural standpoint, lava barriers are not as complex as hydraulic structures or concrete dams. In essence, they are massive earthen embankments built up layer by layer, with each layer approximately 1 meter in height. The key difference lies in the material used and the nature of what they are designed to stop. Lava does not seep through soil the way water does. With its high viscosity and extremely high temperature, it primarily flows across the surface and is strongly influenced by elevation and terrain shape. This allows engineers to focus on increasing the height of the barrier rather than dealing with complex foundation work. As long as the barrier is high enough to slow the flow and force the lava to change direction, it fulfills its purpose. When necessary, the wall continues to be raised 1 meter at a time until the lava naturally stops or shifts to another path. A massive machinery fleet. To achieve that speed, Iceland had to mobilize a heavy earth-moving fleet, rarely seen assembled at a single construction site. On the ground were Komatsu 375 Liebherr 776 Caterpillar D11, along with large numbers of articulated dump trucks. The scale of machinery was not meant to showcase size but to reflect a harsh reality. Every hour that passes allows the lava to advance further. Only by moving material at maximum speed could the wall stand a chance of staying ahead of the molten rock. Building the barrier. The construction of the barrier begins directly on lava that is cooled and solidified after previous eruptions. Over time, this lava forms thick, heavy basalt rock that is extremely difficult to break apart. Heavy bulldozers use ripper teeth to fracture this rock, concentrating the machine's full weight onto individual contact points to crush the material. Once the rock is broken into smaller pieces, bulldozers push it into large piles so that excavators can load it onto trucks, which transport the material continuously to the wall construction site. There, the old lava is dumped and compacted layer by layer. with each meter of height calculated in advance. At this site, what once destroyed infrastructure is reused as the primary material for the barrier, forcing new lava flows to slow down and change direction. Infrastructure affected by lava has no intent or strategy. It simply flows under the force of gravity, moving across the lowest terrain and destroying everything in its path. From roads and power infrastructure to residential areas, many locations are forced to be abandoned entirely once the molten rock moves through. In that context, the people of Iceland do not choose panic or attempt total control, but instead accept and adapt at certain moments. The heat from lava flows is even used to cook food, not as a reckless flirtation with danger but as an everyday gesture that reflects a deep familiarity with a land where volcanoes are always present. This is the calmness of a society that has learned to live alongside volcanoes, understanding the limits of technology and focusing on protecting what matters most within the time that lava barriers are able to provide. Bombing lava, but humans do not always have enough time to build barriers. When lava flows are only a few dozen hours away from critical areas, constructing an earthen wall becomes nearly impossible. This reality was clearly exposed during the Reykjanes eruption in 2024, when lava not only overtopped earthen barriers through newly formed fissures but also broke through sections built on paved road surfaces, where low friction allowed the molten rock to pass through more easily. In such emergency situations, humans have at times resorted to more extreme measures. In Hawaii in 1935 and 1940, military aircraft dropped approximately 600-pound bombs into lava tubes of Mauna Loa. The objective was not to stop the volcano but to disrupt the structure of the lava flow, forcing it to spill out at the blast site instead of continuing downslope. This method did not produce consistent results. Some attempts slowed the lava flow only briefly, while others proved completely ineffective. Yet in situations where few options remained, attempting intervention despite the risk and uncertainty was still considered preferable to standing by and watching the lava advance. Cooling lava with water. History has recorded several cases in which humans successfully intervened in lava flows using simpler methods. A notable example is the 1973 Eyjafell eruption in Iceland. When lava advanced toward the harbor, seawater was sprayed directly onto the lava flow, cooling it and causing it to gradually solidify. At the surface, this cooled layer formed a natural barrier, forcing the flow behind it to change direction. Although this method cannot extinguish a volcano, it shows that under the right conditions, humans can slow and redirect lava enough to protect critical infrastructure and buy additional time. Growing grapes on former lava fields. Most efforts to stop lava from explosives to earth and barriers are aimed solely at buying time. And when that time is long enough, humans not only repair what has been destroyed but also learn to cultivate the very land that was once scorched. Located at elevations between 400 and 800 meters above sea level, volcanic slopes possess rare natural conditions. The soil formed from cooled lava is rich in minerals, particularly potassium, magnesium, and iron, elements essential to grapevine development. The porous rock structure allows water to drain quickly, forcing vine roots to grow deep into the ground in search of moisture, resulting in stronger and more resilient vines. Most vineyards are oriented toward the southwest. During the day, they receive just enough sunlight to drive photosynthesis. At night, the temperature difference between day and night slows grape ripening, allowing sugars and flavors to accumulate in balance. Over time, hills that were once barren become covered with lush vineyards. Each year, local growers harvest thousands of tons of high-quality grapes. When new vines are planted, each one is placed in a hole approximately 40 centimeters deep, with the soil mixed with organic compost and volcanic ash. This mixture helps the roots quickly anchor into the ground while absorbing minerals left by previous eruptions. The dry, windy climate of volcanic regions creates ideal conditions for the development of thin-skinned grape varieties. This thin skin allows grapes to absorb sunlight at a moderate level, while limiting excess moisture, a factor that often leads to disease in viticulture. After approximately 3 years of careful cultivation, the vines begin producing their first harvest. Harvesting typically takes place in the early morning when the air is still cool and a light layer of mist covers the grape clusters. This helps preserve natural moisture and reduces oxidation before the grapes are transported to the winery. After each harvest season, tons of ripe grapes are collected from hillsides covered in volcanic ash. Depending on weather conditions in the vintage, each hectare of vineyard can yield between 8 and 12 tons, a significant figure for land once considered impossible to cultivate. After harvest, the highest quality grape clusters are transported to the winery the same day to preserve freshness and natural sugar content. There, the grapes are thoroughly washed to remove dust, volcanic ash, and remaining impurities before being destemmed and fed into a sealed pressing system. The pressing process is carefully controlled to extract clear grape juice, while minimizing the release of compounds that could make the wine harsh or overly astringent. The juice is then transferred to fermentation tanks, where natural yeast converts sugars into alcohol and develops flavors characteristic of the volcanic terroir. After fermentation, the wine continues to age in oak barrels for several months to stabilize its structure and build depth of flavor. Once the desired maturity is reached, the wine is bottled and stored further in cool cellars before being released, becoming the final product of land once covered by lava. Overall significance: at first glance, lava is always associated with destruction. It swallows roads, buries homes, and forces people to abandon lands that have been part of their lives for generations. But when viewed across the full history of how humans have confronted lava flows, its meaning does not end with devastation. Lava becomes a measure of the limits of technology, of how humans choose to confront, adapt to, and ultimately redefine their relationship with nature. In barrier-building campaigns, lava is a threat that must be slowed. Earthen walls, rock embankments, and artificial barriers are not designed to defeat a volcano, but to buy time. This reflects a clear reality. Technology can only redirect, not exert absolute control. When time is no longer sufficient, humans have turned to extreme measures such as bombing lava tubes, risky efforts that reveal a desire to intervene more deeply in forces beyond human control. Yet the most profound meaning of lava emerges after it cools. Lands once scorched gradually become mineral-rich ground where grapevines take root and thrive. Lava, from a symbol of destruction, becomes a foundation for renewal. In that process, humans no longer seek to resist it but learn to utilize it and live alongside it. From this same basalt layer, geothermal water filters through and forms the Blue Lagoon ecosystem, creating a unique environment that is both healing in nature and a defining economic ecological symbol of the nation. From barriers and explosives to lush vineyards, lava reflects a consistent principle. Humans do not conquer nature through absolute force, but through adaptation, patience, and the ability to turn hazard into opportunity. Outer lava barriers do not stop volcanoes, but they give humans more time. In Iceland, earthen walls are not built with the belief that lava can be completely blocked. They are constructed to protect what can still be preserved: infrastructure, energy systems, and people. In this confrontation, there are no perfect solutions, only decisions that must be made very quickly, in conditions where every mistake carries a cost. When lava cools, life does not return to what it was before. It returns in a different form, more cautious, more aware of its limits, and better adapted to the landed inhabitants. Because after every lava flow, what remains is not only rock, but lessons about how humans coexist with nature. So what are the true limits of humanity in the face of immense geological forces? Continue following Quantivox Tech to explore stories of technology, engineering, and people behind the most extreme geological phenomena on Earth.